Welcome to the session. So in this particular video, we will talk about the concept of tabulation and memoization approach with respect to the Fibonacci series. I hope that before coming to this video, you already have watched my introductory session of dynamic programming, where we have seen that at what point of time we should go for dynamic programming approach, right? Whenever there is a overlapping subproblem. Apart from that, we have seen that what is memoization, what is tabulation, or in other words, what is top-down approach and what is bottom-up approach, right? With respect to the Fibonacci series, I have explained all the concepts in the previous part of my video. In this part, we will try to discuss the coding aspect of the same. So here if you will see, I already have a file. Here if you will try to observe what we are trying to do. If you remember, at the very first part, we have discussed the recursive approach. And as I told you that recursion plays a very important role in dynamic programming as well. Because if you remember, what we are trying to do in memoization approach, we are trying to store the results of the recursion so that we will not need to do the computation again and again of the same term, of the same function calls. And that's where we are trying to optimize our time complexity from exponential to the linear one. I hope everyone agrees with me with that part. Now, here if you will observe, the simple recursive approach will be that this is the base case condition that we have, right? Where we are saying that if the value of n is either 1 or 2, give me the result as 1. Otherwise, what we are saying, we are calling the recurrence relation here. Because we know that in case of Fibonacci series, the last two numbers, summation of that will be the result. So what we are trying to do is that we are trying to just add these two numbers, n minus 1 and n minus 2, and we will be able to get the result. And in this way, we will be able to return the result. And now if I will try to run this fib of 5, I will be able to get the correct answer, which is nothing but is equals to 5, right? Similarly, if suppose I will solve for fib of 40, I will be able to get the answer. But if you will observe here, it is taking the time to do the computation. You can see below it is trying to execute so many function calls. Why? Because it is trying internally to create that recursive tree and it is trying to solve the same, function calls again and again. If you remember the example of fib of 5, there was only one overlapping, which is fib of 3. But if I am typing fib of 40, at that point of time, it might be really huge. So that's where I am saying that the time required to execute the code is pretty much high. If suppose I will increase this number, let me try to increase the number to maybe 100. Okay, let's see. I'm not sure that whether it will be able to, give me the result within the time frame or not. But what we are observing here, we are observing one simple thing, that when we are doing with the approach number 1, where we are simply using the recursive approach to calculate the fib of n, and as I am increasing the value of n, what is the inference? The time required to execute that code keep on increasing. So this is the inference. So what is the inference? That as we increase the value of n, the time required to execute the code is also increasing. That is the one foremost thing which we are observing here. Why it is happening? Why it is happening? Due to the problem of, or I would say due to the overlapping subproblem, right? What is that? We already have discussed in our previous class. So this is the important inference that we will be able to get here. Fine. So this is fine, right? After that, this is also fine. Now we will be able to get this thing. So here if you will observe, still I am not able to get the answer. So I am not running it beyond. So I am just stopping it down. But here you can see that it is taking a lot of time, right? I just want to show you the things. I can't wait too long to execute this file. Here if you will see, then to avoid this problem, we are using a dynamic programming approach. I am solving this approach using a memoization. So what we have talked about in memoization, we have seen that what we are trying to do here, we will call the recursive function again, but now I will try to store my data inside the table. So here I am creating one table called as memo. Initially I am initializing all the values with none of size n plus 1. And now I am calling the function fib underscore top down, because we know memoization approach is also known as top down approach. Now here what we are trying to do is we are passing the number n, which we want as a Fibonacci number. For example, I am passing 5 or I am passing 7 or 10 and so on. But apart from that, I am also passing the data, that array where I am storing the data, right? Now what I am saying is that if suppose the value is not present inside that particular array. So here if you will observe, the very first point is check is happening. If the value is not present, then we will execute the below part. If it is not none, then we can directly return that part. So this is quite important. So here basically storing of the results of function calls is happening. So if it is not none, we can directly return that, which will take big O of 1 time complexity. Otherwise, we will try to do the computation of the function call, right? Otherwise, we will try to do the computation. So again, it will remain same. This is the base case condition that we have, which is saying that if the value of n is equals to 1 or 2, again, just store the result as 1. Otherwise, now here if you will observe, again, there is recursive function call which is happening. Recursive function call is there where we are calling n minus 1 and n minus 2. But now what is the difference between this code and the above one? Here I am not passing any memo array which is storing the result. Here if you will observe, I am passing with respect to n minus 1 one array called as memo, which is basically used to store the results. And then this result, whatsoever I am getting, I am storing it inside the array named memo. So we are trying to initialize an array to store the results. We can say list to store the results of the function calls. In this way, we will be able to avoid the overlapping sub-problems, can we say? So now whatsoever result we are getting, we are storing it and then we are returning that. Okay, fine. So if I will try to run this, fib of 5, fib memo of 5, I am getting the answer. If I am saying 40, I am again getting the answer. Now if suppose I will pass maybe 100 here. So let me pass fib underscore memo of 100. Let's see what we will be able to get. We are getting the result fast. That is good as comparable to the above recursive code that we have seen. If I will pass maybe 500, let's see what will happen. It's better. It's better. We are working in a good way. It means if I will pass maybe 800, let's see what will happen. Now, perfect. Within seconds, again, I am able to get the result. Now, if I will pass 1000, let's see what will happen. Here, if you will see what we are getting, maximum recursion depth exceeded in comparison. It means that when I am passing 1000 number, there are so many recursive calls which are happening internally. Even though I will be able to avoid the problem of overlapping subproblem, but still recursion is there, right? So this is the recursion error which we are able to get because of the too much depth of the recursive tree. How can we avoid this problem? So this problem can happen when the value of n is too large. At that point of time, there is another savior that we have, which we called as a tabulation approach, which is a bottom-up approach. So here if you will observe, we are not using any kind of recursion. So what will happen? We are basically again trying to pass a base case condition. So I can say that this is again a base case condition only. But here what we are trying to do, we are trying to again using the table or the array or the list that you can say, initializing with n plus 1. But here the approach is little bit different. How? If you will observe here, there is first of all no as such recursive call that you will observe, right? One more thing, what we are trying to do, we are trying to initialize the value of 1 and 2. Because anyhow we know that in a table, the value of fib of 1 is 1, the value of fib of 2 is also 1. So what I am trying to do here is that I am trying to initialize the value of 1 and 2 with 1. And then I am starting from the value 3 until the value of n plus 1. So in worst case scenario, so the range will go from 3 to n, right? I hope everyone knows the range function. Whichever value you are writing at the stop point, it will go until stop minus 1. So here it will go until the value of n. That's why we are writing the value of n plus 1 here, not n. So what I can do, I can just say, just add the previous two numbers which are present in the table and you will be able to get the result. Now if suppose I will try to run this code for the 5, for the 40, even for the 1000, I will be able to get the answer very instantly, right? Why? Because here there is no as such concept of recursive tree which is generated. There is no as such concept of function calls which are happening here internally. No extra storage space as a stack space we are using. Even though if you will observe, we are using something called as a separate array or a list. But this also we can avoid. We can also, so here the space complexity is big O of n. Because somehow I am using one extra space to store the results, right? If I want to avoid this also, so how we can avoid this? We can avoid this by just storing the value of previous 1 and previous 2 as 1 and 0. We can start with 2, go until n plus 1, and we can say that the current value is something which is the addition of the previous 1 and previous 2. So in this way we will keep on adding the past two values, which is prev 1 and prev 2, and then we will keep on updating. So whatsoever be the value of previous one that we have, we are just passing it to previous 2, and whatsoever be the value of current that we have, that will become the previous one. And finally we can return the value of the previous one. So in this way, if you will observe, if I will just call this, I will be able to get the answer. If the value of n is suppose 10,000, I will be able to get the answer very instantly of the very high number as well. So in this way, you are trying to reduce the space as well. So here if you will observe in the very last approach, which is the highly optimized approach, because here I am optimizing the space as well. I am not using any extra array here to generate the results, right? So there is no recursion. The very important thing to understand here, that here we are not using, there is no recursion which is happening in tabulation approach. We are just trying to add the previous two numbers to get the result. That's the ultimate thing that we are doing here, right? And even if I will go ahead towards the space optimization part, here also if you will observe, I am not using any kind of a space as well. Here I was initializing one array of bottom up whose size is n plus 1. But here if you will observe, I am not doing that thing also. I am just using two variables, and with the help of that, I will be able to solve this particular problem within a, I would say, constant space complexity. So I hope that I am making sense to everyone. Even though if you will observe, when I was using this approach, if I will talk about the time complexity aspect. So what is the time complexity of this approach? We have discussed in our last class as well, the introductory class, that it is big O of n. Because we are in a way calling n function calls, and we will be able to avoid that overlapping subproblem in memoization approach. But when the number of n is very high, that recursion depth error is coming up. Here also if you will see, I am using the extra space called as space complexity, which is equals to big O of n. Can I say? Right? We are extra using the space memo, right? So space complexity is something where you are using an extra space. Even when you are going for a tabulation approach, which I just showed you, here also if I will talk about the time complexity, you will observe that the time complexity is okay, fine, big O of n. But here also when I am talking about the space complexity, we are using in a way extra space, that's why it is big O of n only. But when I will talk about the third approach, here if I will talk about the time and the space complexity, So the time complexity is something because we are applying only one for loop, right? It will be big O of n. But when I am talking about the space complexity part, so it is something which is equals to constant, because with the help of only two, I would say, variables, I will be able to get the final result. So this is the overall idea about how we can solve any problem using the dynamic programming. So out of these two, if I will say to you that, can you tell me out of this memoization and the tabulation approach, which one is more effective? So I think everyone can answer this, right? Memoization is good because there we will be able to avoid the overlapping subproblem. That is fine. We are able to avoid it in both of the cases. But somehow tabulation is, I would say, much preferable as comparable to memoization. Why? Because we are not using any kind of recursion there. That's why it's easy to compute. But usually what happened is that because we have solved so many recursive questions in divide and conquer module as well, so we will be easily able to solve any memoization approach. So if in an interviewer is asking to you some question, first of all, try to go for the recursive solution. Try to see that can you generate some kind of a recurrence relation of the same. Can you solve that with the help of any recursion method? You will be easily able to find out. Then see, after seeing the recursive tree, if you will try to break down, check that is there any, I would say, overlapping subproblem exists or not. If suppose that problem is there, then you can talk about the dynamic programming. Inside the dynamic programming, the very first approach is memoization, because if you know the recursive solution of the same, memoization is very easy. It's just that you are storing the results. Then after that, after completion of that approach also, you can talk about the tabulation approach at the very end, right? This is the way, this is the sequence of approaching towards the problem related to the dynamic programming. I hope that this video is pretty much useful to everyone, and now you will be able to get a very good insights about the dynamic programming. Now what we will cover up in our next upcoming video, we will try to see further applications of DP, which will for sure help you to enhance the concepts of dynamic programming. I hope that until so far everything seems to be very easy. It's just a term which is, it's just a hype that it's very difficult, I would say. But if you will try to understand the concepts, it is really simple and very easy, right? With this, I would like to end this particular session. I will see you all in my next upcoming video, where now we will talk about the next new application of dynamic programming. Bye-bye everyone, and take care.